After finishing construction on the Starship's smaller version, Starship Alpha or Starship Hopper, during the holidays, SpaceX began testing its new Raptor engine in late January, early February 2019. According to Musk's concept, these engines will provide the Starship with the required thrust to reach the Moon and Mars. However, success brings some questions, such as, can SpaceX and Blue Origin outperform a decades-old Russian rocket engine design? Is SpaceX's Raptor 2 rocket engine the most powerful in the world? It's difficult to say, but stay tuned until the end of the video to learn more. An unusual rocket blasted out from Launch Complex 36 at Cape Canaveral Air Force Station an hour before sunset on May 24, 2000. The Atlas III, like other rockets, was based on an intercontinental ballistic missile, in this case, America's very first missile, which was meant to threaten the Soviet Union with nuclear devastation. This was not out of the ordinary. The rocket, however, featured a first new stage, which was far more powerful than the ones it replaced. The engine, known as the RD-180, was developed by NPO Energo-Mash in a plant south of Moscow. A Russian engine was powering an American rocket, which would have been unthinkable at the height of the space rivalry. At least 16 American spy satellites into orbit on the Atlas III and its successor, the Atlas V, as well as 13 military communications satellites, a half-dozen GPS satellites, 2 military weather satellites, and 3 missile warning satellites, all of which were designed to detect rocket launches from countries, including the one where it was built. It was responsible for the launch of 4 American missions to Mars. The RD-180 was used to launch NASA's New Horizons mission to Pluto in 2006, and the Juno mission to Jupiter in 2011. The RD-180 is noteworthy not just for the geopolitical events surrounding its rise to fame, but also because it was, in many respects, superior to any other rocket engine available at the time. Elon Musk boasted of the high pressure attained in the Raptor's thrust chamber when he announced the successful test of SpaceX's Raptor engine in February 2019, which is designed to propel the company's next-generation rocket, Starship. Testing went extremely well, Musk tweeted, reaching the thrust required for both the Starship and its first-stage rocket, the Super Heavy. Musk also claimed that the engine shattered the Russian RD-180's previous record for combustion chamber pressure. Let's go back a bit and give you a little backstory. The RD-180 was developed during the Soviet period as part of the Energia rocket program, which aimed to develop a super heavy launch vehicle capable of launching the reusable Buran spacecraft, Russia's equivalent of the space shuttle, into orbit. The engine survived the program's cancellation and was even transferred to the United States, where it was used in Lockheed Martin's Atlas III and the United Launch Alliance's Atlas V rockets. The RD-180 and its predecessor, the RD-170, maintained the record for highest combustion chamber pressure for decades at 26.7 MPa, 3,870 psi, and 24.52 MPa, 3,556 psi, respectively. However, 3 days after Musk tweeted about the first Raptor's performance, he announced that the chamber pressure had reached 268.9 bar, which translates to 26.89 MPa, 3,900 psi, indicating that the Raptor's performance had improved, establishing a new record by about a 1% margin. Musk was questioned if this performance has anything to do with SpaceX's plan to power the engines with a mix of cryogenically supercooled liquid methane and liquid oxygen, LOX, which will supposedly provide a 10 to 20% increase over conventional engines. Musk said no, claiming that the methane and LOX fuels were barely maintained below liquid temperature during the test firing. Musk expects the engine to attain its goal chamber pressure of 300 bar, 4,350 psi, while held at cryogenic temperature, but said that just 250 bar is needed for nominal functioning of the Starship Super Heavy. If this is accurate, the Raptor will have broken the previous performance record by a substantial margin of 11%. This is all preliminary data, and the Raptor has yet to work as part of a larger system. The RD-180 still has the advantage, with over 20 years of experience attaining chamber pressures of up to 257.5 bar, 3,735 psi, on a regular basis on board the Atlas V rocket. But is that all in the past? Well, more on that later in the video. The RD-180's days as a mainstay of American rocketry were numbered when Russia took Crimea in 2014. Defense hawks had long objected to the arrangement, but the engine was both excellent and inexpensive for its capabilities, so it remained. However, when ties with Russia deteriorated, opponents of the engine in Congress, headed by Senator John McCain, were able to enact legislation prohibiting the engine's use on American rockets after 2022-2023. This forced the Air Force to rush to develop a new rocket to replace the Atlas V's RD-180 engine. However, it appears that Russia has taken the step to halt its supply since Russia has said it would no longer export rocket engines to the US. Roscosmos, Russia's governmental space organization, has made yet another threat in reaction to international sanctions, alleging that Russia will no longer provide rocket engines to the US, although most rocket launches in the United States should be unaffected. the decision may alter how cargo is delivered to the International Space Station. The decision will largely affect two U.S. companies, United Launch Alliance, a critical launch provider for NASA and the U.S. Department of Defense, and Northrop Grumman, which launches supplies to the International Space Station for NASA on a regular basis. Both firms rely on NPO Energomash's Russian rocket engines to get their spacecraft into orbit. However, as it transitions to a new vehicle with an American-made engine, ULA maintains that it already has all of the Russian-supplied engines it requires for its rockets. Northrop Grumman's future vehicle flights may be halted as a result of this decision. All of this raises the issue of how a decades-old Russian engine came to be the yardstick by which America's top rocket scientists are judged. If you want to know what went into making the RD-180 such a fantastic engine, you should know that it took a lot of skill. Despite the fact that hundreds of people work on rocket engines, having someone in control with a design instinct is critical. The trade-offs are too complicated to be worked out by sheer force or by committee. Valentin Glushko was that person in the case of the RD-180. According to Vadim Lukashevich, an aerospace engineer and Russian space historian, after the USSR lost the race to the moon to America, creating the finest possible rocket engine became a national priority. The Energia, the world's most powerful rocket, was designed by Soviet officials to support their space stations in Earth orbit and lift the Buran, a potential Russian space shuttle. Glushko was given the resources he needed to make the finest engine he could, and he was an expert at it. The RD-170, the RD-180's older sibling, was the outcome. The RD-170 was one of the earliest rocket engines that employed a staged combustion approach. Another was the main engine for the US space shuttle, which was designed in the 1970s. On the other hand, the F-1 engines of the first stage of the Saturn V rocket that took Apollo to the moon, on the other hand, were of an older, simpler type known as the gas generator engine. However, like the F-1 engines, the RD-180 appears to be old. Raptor 1 has been improved over time, but it is now an outdated design. It has a complicated design, is tough to make, and has a long time between launches. It also has a thrust ceiling of 185 tons, which means it won't be able to meet Musk's requirements for a Mars-bound Starship. The Raptor 2, a SpaceX engine capable of propelling us to Mars and beyond, is the company's solution. This isn't simply a redesigned Raptor 1, but a whole new design that outperforms its predecessor in every category. So, how did SpaceX accomplish this? By making the design simpler. The Raptor 2's engine is still a methane liquid oxygen combination. However, the similarities, end there. First and foremost, turbo machinery has been replaced with a simpler and more powerful unit. More gasoline may be fired into the engine as a result of this. The combustion chamber, nozzle, and electronics have been totally redesigned to make the most of this extra fuel. The Raptor 2s are also welded together, decreasing the number of parts required. The Raptor 1s, which employ flanges to physically put the engine together, are more compact, lighter, and easier to construct. Finally, unlike Raptor 1, the Raptor 2's pre-burner controls are contained in their own box, rather than being dispersed throughout the engine. This simplifies production and removes the shroud, which allows for more movement in gimbaling engines. So what do all these changes imply? The Raptor 2 generated 247 tons of force during static testing, and experts believe it will soon reach 250 tons. That's a 35% increase in thrust from a smaller, lighter engine. As a result, any rocket outfitted with the Raptor 2 will be able to carry a much larger payload. It doesn't end there though. Raptor 2's simplicity allows it to be relaunched in less than an hour, instead of Raptor 1 several weeks between launches. Because of its simplicity, the Raptor 2 costs half as much to produce as the Raptor 1. It's an understatement to say that this engine is revolutionary. The Raptor 2 will have a huge impact. Let's take a look at Musk's ultimate ambition, which is to colonize Mars. A small fleet of Raptor 2 equipped starships may launch many times a week thanks to the Raptor 2's speedy turnaround. This implies that SpaceX might launch more payloads into orbit in a year than the United States has ever done in its history. SpaceX will be able to colonize Mars because of this huge increase in yearly cargo capacity. Musk thinks that a self-sustaining Mars colony will require a total payload of 1 million tons. Raptor 2 equipped starships could theoretically deliver this much to Mars in 10 years, with approximately 20 launches per week. With the present state of things, it appears that the RD-180 may be a thing of the past, but who knows? Let us know what you think of the RD-180 in the comment section below. And do you believe we'll ever go to Mars? And if so, would you go if you had the chance?